Hello there, beautiful people. So this is going to be covering the properties. We're going to go over numbers 6 through 9 here, these lovely properties of all different quadrilaterals. So tune in for a very exciting time with Miss Coffee. Okay. Oh, wait, but before we begin, I've been requested to do this at the beginning of the video instead of the end, so that way your mind can mentally prepare for the math that's about to happen. Ready? Okay. Yay, math! Yay, math! Okay, great job. That was fun. Okay, so again, we have different versions. So I'm just going to go through this one, but the other version was the same questions, pretty sure, just mixed around. Maybe the answer choices mixed around other questions, but I'm still testing you about the same things. There's no other way for me to ask you these types of questions. So, for number 6, let's look at that. Which of the following properties is always true for a parallelogram? Okay, so if that was your question, maybe it was another one somewhere. Which of the following is always true for a parallelogram? So we need to think about the properties of parallelograms. Okay, there's a lot of properties, but what I'm testing you on is about the diagonals. I'm sorry, Miko's being so cute right now. Miko, stop it. He's so cute. Oh my goodness. Just want to cuddle his face. Okay, all right, I'm done. Sorry, had to give him some pets. Okay, so anyway, let's talk about parallelograms. So I'm just going to talk in general. So I'm not just going to tell you the answer because that's not going to help you. I'm going to explain and we're going to talk about all of these different properties. So in a parallelogram, definition is that the opposite sides are parallel. Okay. And then you have some other important properties. So you have that the opposite sides are congruent. Okay. You have the opposite angles are congruent. So those are congruent and these are congruent. Now it's getting kind of messy. And then you also have that the consecutive ones are supplementary, so those will add up to 180 and those will add up to 180. Sorry. Okay, but there's one more important one that you had to know about the diagonals. So, let me redraw this. In a parallelogram, the diagonals will always be perpendicular. What? No, Miss Coffee, you're crazy. I'm sorry, I'm not thinking. Okay, let me draw and then I'll talk. So, the diagonals will always bisect each other, meaning these two are congruent and these two are congruent. So that right there is a property of all parallelograms no matter what. Okay? Okay. Now, if I had said, well, let's just go through the other ones. So the diagonals are perpendicular. That is not always true. Keep in mind these key words, always. It's not always true for parallelograms in general, because as you can see in this example, these angles are not forming a 90-degree angle. Okay, that one clearly looks like it's obtuse, and this one looks like it's acute. Okay, so they're not perpendicular. Okay, that is applied to rhombi and squares, because squares are a type of rhombi. Diagonals are congruent. No, that's not true for all parallelograms. That is true specifically for rectangles, which are types of parallelograms. But again, it's asking which of the following properties is always true for all parallelograms, no matter what. Diagonals bisect opposite angles, even though it says bisect here and here. It's talking about opposite angles now. Okay, so that is not true for all parallelograms. That is only true for rhombi and therefore squares, because squares are a type of rhombus. Okay, so my answer for this one is A, the diagonals bisect each other. Got it? Got it. Okay. I'm going to skip down while we're on that to number 8 here because it's very similar. It even has almost the same answer choices. But now it's saying which of the following properties is always true for a rectangle. Okay, so rectangle, remember, is a type of parallelogram. So it's going to have all the properties of a parallelogram. And what did we just say was a property of parallelograms? That, oh, not that one. That the diagonals bisect each other. Oh, that's not there. So that's not an option. Okay, and then what other things we know about rectangles is they have 90-degree angles. And the important thing in this example is that the diagonals, like I said before, are congruent. So only for a rectangle are they congruent, and obviously a square, because remember, a square is a type of rectangle. So diagonals are congruent for a rectangle. Let's go through the others just to make sure you understand why those are not correct. Diagonals are perpendicular is for rhombi again, and therefore squares. That's not true for rectangles. Same thing for bisect opposite angles. That's for rhombi and squares, not rectangles. Now, this last one was a little weird. I realized after that it really doesn't make sense. Base angles are congruent. There really aren't base angles in rectangles. That's a term we use for trapezoids or isosceles triangles. So if you had put B and D as your answer, I counted that correct. Because technically, if you want to consider these two your base angles, they are congruent, right? Because they're both 90 degrees. So I would say you can say both of those. But if you just put B, I also counted that correct because that's what I was looking for there. Now, if you had said just D, I don't know that I counted that correct because I'm definitely looking for diagonals are congruent. Have to have that information. But for this one, I think I told you guys there was only one answer, and so I really was only looking for D. I'm sorry, B, not D. Okay, got that? All right, so that was given the shape, which of the following are properties. Now we're going to switch it around. Given a property, which quadrilaterals have that particular property? So let's look at number 7 here. Which of the following quadrilaterals always have diagonals that are congruent? Oh, it sounds like we were just talking about that. Remember we said that is a rectangle. So these two are congruent in a rectangle. Okay, so definitely going to choose that as my answer. Let's go through the rest of them though. In parallelograms, no, they're not congruent. Think about it. Parallelograms are like a slanted rectangle. So that slant that's applied to the parallelogram makes this diagonal much longer than this other diagonal here. Okay, so they're not congruent in parallelograms. They are not congruent in rhombi. Because again, rhombi are like slanted squares here. So that slant is going to give us different lengths in our diagonals. Okay, it's actually the 90 degrees that allows us to have congruent diagonals. Okay, and squares. What do you think? Diagonals that are congruent? They sure are, because they have 90-degree angles. Square is a type of rectangle. Therefore, it has all of the properties of a rectangle, like congruent diagonals. And then a lot of people forgot about this last one, isosceles trapezoid, which I did give partial credit for this problem. So if you bubbled B and D, you got most of the points, but you were missing the isosceles trapezoid. In an isosceles trapezoid, because these legs are congruent, that means my diagonals from here to here and here to here are congruent. Okay, so you just need to know isosceles trapezoids have congruent diagonals. Cool, cool. Okay. Last but not least, which is fine, quadrilaterals always have diagonals that are perpendicular. Okay, so let's go through those. Parallelograms do not have perpendicular diagonals. Okay, so no. Rectangles, no. Remember, they have congruent diagonals. Here, I'll make little notes here. Parallelograms have bisecting diagonals. Rectangles have congruent diagonals. Rhombi have perpendicular diagonals. So my rhombi here always is going to be 90 degrees. Okay? And because a square is a type of rhombi, rhombus, whatever. That also has congruent diagonals. And then hopefully you didn't forget about this last one here. Kites also have perpendicular diagonals. It helps for you to draw out the pictures just to see, kind of verify. Yep, that looks 90 degrees. Okay, so those are your options. So in general, let me just explain what you need to know about the diagonals. It's very simple. You have parallelograms, and under the parallelograms category, you have rectangles and rhombi, all right? So all the properties of parallelograms, which is basically the one you need to know, is that the diagonals bisect, okay? Rectangles have all those properties, right? So that applies, and for rhombi, that also applies. And they have an extra property. They have congruent diagonals for rectangles. For rhombi, they have perpendicular diagonals, and the diagonals bisect the opposite angles. Okay, and then the rectangles and the rhombus get together, they make a baby, and they make a square. A square is a type of rectangle and rhombi. So a square has all the properties of parallelograms, rectangles, and rhombi. So it's got all the things. Okay? And then separately, you need to know that trapezoids are quadrilaterals with one pair of opposite sides parallel, and consecutive angles are supplementary. So they add up to 180 here, and they add up to 180 here. And a special type of trapezoid is the, oops, I need to spell, isosceles trapezoid, which has congruent diagonals, like this, okay? Congruent diagonals, congruent base angles, right? And last but not least, you need to know all the properties of kites. Actually, mostly you just need to know that they have perpendicular diagonals. Okay, but then you need to look at that worksheet because there were other properties. Consecutive sides are congruent. One pair of opposite angles are congruent. Bisects this one here. Okay. All right. So study that, and hopefully you'll do better on your retest. Okay. Bye.